The quadratic formula. Let's say we have a function x squared plus 2x minus 3. You can spot that this is a quadratic. We can use the quadratic formula to find the roots of this graph. We start by substituting the coefficients of the function into the formula. And let's simplify this. And we have found the two intersections of the function, which is at x equals negative 3 and x equals 1. Let's derive the quadratic formula. We start with this equation, which is the general form of the quadratic equations, and the main goal in this video is to solve for x, and as we do so, we will end up deriving the quadratic formula. I suggest you to pause it and try it on your own. A hint is, try using completing the square to solve for x. For using completing the square, we need to have a coefficient of 1 for our highest degree term, which in this case is x squared, but we have a as the coefficient of x squared. We have factored a from the first two terms. Now as the coefficient of x squared is 1, we can use completing the square. Now as you see, we have used completing the square to get this equation. We can also move c to the other side, so we just have the x terms on the left. In the right side, we have a denominator 4a, so we can multiply 4a to c so that we have a common denominator. And now, as the fractions on the right side have a common denominator, we can group them and write them as one fraction. We are solving for x, and we can see that the term which is a is being multiplied to it, so we can straight away divide to move it to the other side. Again, we see that x is being squared, which is a simple step in order to simplify to find x, which is taking the square root of both sides. We now just have b over 2a left on the right side, and we can subtract it in order to move it to the other side of the equation. Now, you see we have a common denominator, so we can group the fractions as 1. And there, we have derived the quadratic formula.